Now we're going to do square roots of parabolas. But the same steps will apply. Now in all of these examples that we do in the notes here, they're giving us the graph already. But I'll tell you that you might just be given the equation and asked to graph. So for example, this red's equation, it's a parabola. Can you see that it's been moved 3 to the right and 4 down? So if we were going to show 3 to the right and then 4 down, that would be the equation of our red graph. And if you check some points, can you see that if you plug in, for example, 5 minus 3 is 2, 2 squared. 4 minus 4 would be 0. Sure enough, we get 5, 0. And the question without the graph given would be as simple as saying, can you graph this? So if you were asked to graph that equation in blue, the first thing you would do is graph the inside, the red equation. And graphing the red equation, you use your transformations, move the parabola 3 to the right, move it down 4, and sketch your graph. And from that graph that you just sketched, which is given to us, you would then go through these steps. Step 1, do I have any points where my y-coordinates are 0 or 1? Yes. Here are the 2 points where the y-coordinates are 0. Here are the 2 points where the y-coordinates are 1. Do I have any other nice points? Step 2. Not really. I mean, you can hypothetically make some nice points if you want. For example, right here, my y-coordinate is 4, right? So if I take the square root of 4 on my blue graph at that same x value, even though I don't know what that x value is, that's where it would be 2. I could do the same thing over here. This is where my y-coordinate's 4, so if I go straight down from that, on my blue graph, that's where it's going to be 2. Now we can go to step 3. Wherever our original graph is greater than y equals 1, our blue graph is going to be below. So our blue graph is going to be below here and here. And wherever our original graph is between 0 and 1, wherever the y values are between 0 and 1, our blue graph is going to be above. And this one in particular, it's going to be really hard to go above without going back in time or forward in time. There we go. It almost will look exactly on top, right? Again, if you would over-exaggerate it here and go back in time, you're going to lose a half mark for that over-exaggeration. So we have to be really careful in this section. State the domain and range. And for this one, for domain and range, I'm going to do it in both set notation and interval notation. In set notation, our blue graph is in 2 different parts. So what we need to show, one part is when the x values are less than or equal to 1. The other part is when our x values are bigger than or equal to 5. So when we have 2 sections like this in set notation, we write the word or in between to say the domain is in this section or it's in this section. In interval notation for the same one, interval notation always starts from your smallest values to your biggest values. So for x less than -1, you would write -infinity to 1. For x bigger than 5, you would write 5 to infinity. And instead of writing or in interval notation, we write a big U. For our range, Range is easier here, just y values are bigger than or equal to 0, which you could also write in interval notation as 0 to infinity. So the techniques for if you were given a line or given a parabola are exactly the same. In fact, that techniques or those steps that we wrote in example 1 are going to be the same for any graph. Now, in these examples, you were given the graph and asked to graph the square root function, but you saw we could do the same thing. I could give you an equation and ask you to graph it, and then if that were the case, you would graph the inside equation first and then apply these steps. Now let's look at what happens with a parabola that opens down. Yes, question?
So for the domain, where it says like x is less than or equal to 1, would you have to write the 5 also, or do you only write 1?
Well, the blue graph has 2 parts. So you do need both of those parts. So in set notation, you'd have this, and you'd have to write the word or. It's in this section or that section. All right, so for part B, do we have any x-intercepts? Yes. Do we have any values where y is 1? Yes. Do we have any nice points? Well, up here we've got 0, 9. Square root of 9 is 3, so we'll have the point 0, 3. I mean, you could look on here. Here's where y is 4. So if I went straight down from that, that's where I would have y is 2. And then we can go to the third part where wherever our original graph has y values bigger than 1, our square root graph is going to be below. Can you see that this is the below section? And whenever our original graph's y values were between 0 and 1, our square root graph has to be above. And this is the part where it might be pretty tough. Your graph might be almost identical on the line. And they're pretty lenient if you're like just barely on, like if you're on the line, they'd be like, well, we can't tell it's below, so we're not going to deduct the marks. If they can tell that your graph is below, even for a little part of it, you're going to get a deduction for not having that part in the correct place. Domain of this one is between -3 and 3. Interval notation, you would write it like this. The range of this one is between 0 and 3. Whoops, square brackets. And question number 8 for practice on this one.